Okay, in this video we'll be doing or continuing our discussion on probability, and I'd like to start by having you look at 18 and let's see if you know your cards. I actually grew up playing cards with the 52 card deck, and so I was always pretty familiar with these, but I found out a lot of my students are not. So try answering the questions and then watch the video. All right, let's see how you did. So first of all, I did tell you there's 52 cards in a deck. What are the suits in a deck? Well, there's hearts, diamonds, spades, and clubs. Now, I actually have an example I can show you guys. Let me make this a little smaller. All right, so these are spades, hearts, diamonds, and clubs. All right, so those are your four suits. Now you'll notice there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 of each suit. 13 times 4, there's your 52. We have aces, so A is for ace, and then the numbers 2 through 10, and then jack, queen, king. The J stands for jack. So for each suit, how many cards are there? We said 13. What are the cards in each suit? Well, it starts with an ace, then then 2, 3, 4, all the way up to 10. Then the jack, the queen, and the king. Which cards are called the face cards? That's these cards. Jack, queen, and king. When you draw a card from the deck, how many possible outcomes are there? Well, there's 52 different cards. So those are your 52 different outcomes. All right, so we like using cards to do probabilities because it gives us some good probability problems. And so again, I would encourage you to try these, and then I'll go ahead and I would watch as I go over them. All right, let's see how you did. So the probability of getting a 3, well, we know that with the 3, there are 4 threes, one of each suit. So 4 threes, there's really 4 of each number or each type of card. So there's 4 favorable outcomes out of a total of 52 cards. So if you reduce that, you see that there's a 1 in 13 chance that you get a 3. Probability that you don't get a 3, well, if 4 of the cards are 3s, that would be 52 minus 4, or 48 cards are not 3s. And if you reduce that, that gives you 12/13. Now you could remember that the probability of something occurring plus the probability it doesn't occur should always equal 1. And so as soon as I see this as 1/13, I know this is 12/13 because those add up to 1. The probability of getting spades, well, there's 13 spades. There's 13 of each suit out of the 52 cards, so that reduces to 1/4, which makes sense. Basically, 1/4 of the deck is spades. Probability of getting a red card, well, half of our cards are red, all of the hearts and all the diamonds. And so 13 plus 13, that's 26, or basically half of 52. 26 out of 52, and you get 1/2. So we know we have a 1 in 2 chance of getting a red card when we draw a card, because half the cards in the deck are red. Probability of getting an even number, well, that would be a 2, a 4, a 6, 8, or a 10. We wouldn't count any of the face cards. And there's, for each of these, there's 4, so there's 5 numbers here, but there's 4 suits, so there's a total of 20 cards out of the 52 that are even. And if you reduce that, you get 5/13. Face cards, well, that's the jack, the queen, or the king. That's 3 cards, but there's 4 suits, so 3 times 4 there's a total of 12 face cards out of 52. And of course you can see them right here. There's 12 right there. Those are my 12 face cards. What's the probability of getting a spade and a diamond? Well, sometimes this tricks students. It's not meant to be tricky, but those are both suits. Each card has one suit. When you draw one card, there's no way you could have two suits on that card. So there's 0 cards that are a spade and a diamond out of the 52, so you get 0. What's the probability that you get a 2 or a 3? Well, there's 4 2s and 4 3s, or you could just do 2 times 4 here. A total of 8 cards out of the 52, and that reduces to 2/13. In probability, the act of choosing a card is an experiment. Remember, an experiment is anytime we go to do something and the outcome is uncertain, like flip a coin or roll a die, that's an experiment. If we want to be more specific, the act of choosing an ace is what we call an event. And events are what we find the probabilities for. All right, let's move on to our last page. So coin probabilities and an application. When you flip a coin, what are the possible outcomes? Well, you could get heads or tails. Again, you might want to try doing at least up to 7, and then we can talk about it. All right, so what is the probability of flipping heads or flipping, well, what is the probability of flipping heads, which we write this way? Well, that's 1 and 2. Probability of flipping tails, that's also 1 and 2. What is the probability of flipping heads or tails? Well, when we flip a coin, we're going to get either heads or tails, so it's 2 out of 2 or 1. What is the probability of flipping a 4? There's no 4 on a coin. It's either heads or it's tails. Those are our 2 outcomes. So 0 out of 2, so we get 0. Remember, probabilities are always between 0 and 1. The act of flipping a coin is called an experiment. The act of flipping heads is called an event. All right, flip a coin 25 times and write your results here. Now you're welcome to do this. This is actually something I do in class, and it's an activity that I use to help students understand the law of large numbers. I'm just going to go ahead and show you one example and I'll talk about what I do. So your answers are obviously going to vary. If you flip a coin 25 times, notice I wrote my results out as I went. And then in this case, there were 10 heads and 15 tails, and so that's what I do. I have each student give me their results. So if you look at it, we're expecting about half the time we're going to get heads and half the time we're going to get tails. Notice here I had more tails than heads by 5. Is that reasonable? I'd say that's pretty reasonable. Now if I had gotten 15 tails in a row, that would be unique. So what is the law of large numbers? So basically, it's the idea that the more times you perform an experiment, the closer the empirical probability, that's what your actual results are, will get to your theoretical probability, which we know is 1/2. So we didn't get half and half here, or not even 12 and 13. So the question I ask my students is, if you flip a coin 100 times, will you get 50 heads and 50 tails? And I think most of us from experience know that's not very likely to happen. However, so in this case, I wasn't very close to, I mean, if you actually do, out of 25 times, the probability we got heads was 10 over 25. So about 40% of the time we were getting heads. We would expect it to be about 50%. So but that's not unreasonable if you flip a coin 25 times. However, if I take the results from the whole class, what we always find is that we're getting closer and closer to that 50%. And that's basically what the law of large numbers says. So the more times you perform the event or the experiment, the more times I flip that coin, the closer the probability should be to, I should say, the empirical probability will be to the theoretical probability. So you flip a coin 1,000,000 times, you're going to be pretty close to 50-50. Half the time getting tails and half the time getting heads. That's the law of large numbers. All right, let's go down here. So we're going to have a little fun here. Assume everyone in your group is going to have 3 kids, just like my wife and I did. Each person needs to flip a coin 3 times. You flip heads, you had a boy. You flip tails, you had a girl. Record your results below. So, for example, I've had my students might get boy, girl, boy, girl, girl, boy, 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 girl, girl, boy, boy. So this was one set of outcomes that we got. Obviously, the results are going to vary. All right, so it says determine all the possible outcomes. Well, you could have a boy first. It could be boy, 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 girl, boy, girl, boy, and boy, girl, girl. Those are all the possible outcomes if you have a boy first. If you have a girl first, it could be girl, 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 boy, girl, boy, girl, and girl, boy, boy. So you got to be kind of systematic to get them all. There's a total of 8 outcomes. And so what is the probability of having 3 boys like Mr. Smith? Well, notice there's a total of 8 outcomes. Total. And there's only one of the outcomes that is all boys, so there's a 1 in 8 chance that you would have 3 boys. What's the probability that you would not have 3 boys? Well, that's all the other 7 outcomes out of 8, and so you get 7/8. Remember, these 2 numbers should add up to 1. The probability that something occurs plus the probability it doesn't occur is always 1. Number 4. What is the probability that your first child will be a girl if you have 3 children? Well, notice there's 4 cases where we got a girl first. So 4 out of the 8, or 1 in 2. So actually it's the same as the probability of having a girl if you just have 1 kid. What is the probability of having at least 1 girl? Well, there's a girl here, a girl here, a girl here. So actually, there's at least a girl, 1 girl, in all but the first option here. So 7 out of 8. So basically, if you have at least 1 girl, that means you didn't have all boys. There's 7 out of 8, 7/8 chance that you have at least 1 girl when you have 3 kids. Mr. Smith and Mrs. Smith have had 3 boys. If they decide to try just 1 more time, what is the probability that they will have a girl? Well, first of all, that's not going to happen. We're done having children. But each time the probability is 1 in 2. And so even though we had a little streak going of boys, it's still 1 in 2 each time. Now some people might argue with that, but from all things I know about biology, the chance is always 1 in 2. Doesn't matter what family you're from or anything else. All right, I do want to say one more thing I forgot about. I want to mention, because this is important when it comes to gambling, and I would just give you a warning. When you do this kind of thing, notice streaks can happen. I got into a streak of 5 times in a row where I got tails. So, and this is very common when you work with probability, you see that streaks happen. So if you've ever watched one of those movies where somebody's winning it big on the craps table or some kind of gambling game, like they're on a roll, luck is with them, you know, and all that kind of stuff. Let's say they rolled a 7 3 times in a row, and they've made $20,000, and if they roll a 7 another time, they'll get $1,000,000. You know, so do you keep your $20,000 or do you roll? Well, all to say, the probability hasn't changed. It's actually a 1 in 6 chance that you'll roll a sum of 7 when you roll 2 die. So my point is, streaks happen, but the probabilities never change. So we could talk about I'm on a lucky streak, but in all reality, the minute you go to roll again, the probabilities are always the same. And so, you know, the one thing I always tell my students is, you know, responsible gamblers will say, hey, I'm going to spend $100 and I'll walk out. You ever go to gamble and you spend more than what you intended, it's time not to gamble. Anyway, Mr. Smith's tip for the day. All right, that's all for this section. That's it.